There's no escaping the fact that climate change is doing crazy things to the weather. Historic heat waves, catastrophic flooding, wildfires, the hits just keep coming. And it's all the fault of excess carbon dioxide in the atmosphere from burning fossil fuels.
The US is betting big on strategies that remove carbon dioxide from the atmosphere to reach its goal of net zero emissions.
The solutions vary from technology that directly captures CO2 from power plants to planting or preserving carbon sinks like forests. But right now, most of these solutions are either really expensive or take a long time. And that's why I ended up visiting a team of scientists here, on the Outer Banks of North Carolina, because they're testing another strategy to draw down carbon dioxide. And they're using this thing. We're in what's called an amphibious vehicle with Dr. Jacqueline Pittman-Setner and a team from the Army Corps of Engineers.
I grew up in Southern California and going to the beach all the time and playing in the waves and the sand and the mud, and incredibly, this is still what I get to do, is play in the waves and the sand and the mud for work, which is so fun.
The Army Corps have been using these surplus military vehicles from the 70s to study the movement of sand along the Outer Banks. So they're a perfect partner to test out the ambitions of Vesta, a startup that's trying to slow down the carbon crisis with this.
Yeah, I know it just looks like sand, but this is actually an abundant mineral called olivine.
It has a slight green hue, which is where the name olivine comes from.
You might know olivine from its gemstone, peridot, which happens to be my birthstone. Hello, my Leos.
But when you add it to the ocean, it soaks up carbon dioxide.
Here's how it works. The ocean is already a massive carbon sink. It stores 40 times more CO2 than the atmosphere, but it can't keep up with our emissions.
That's where olivine comes in. It transforms CO2 into bicarbonate, a harmless form of carbon which is ingested by marine animals. Eventually, it becomes shells or skeletons, and when those animals die, they become part of the sea floor, locking up that carbon for millions of years.
This is a natural process. The Earth has been carrying out this exact reaction for billions of years, and it's one of the planet's natural mechanisms to stabilizing our climate. And all we're trying to do at Vesta is to accelerate this natural process, like on meaningful timescales for humans.
Adding olivine to oceans can solve another climate change issue, ocean acidification, which kills corals and other marine life. Because bicarbonate is basic, it lowers the acidity in the water.
So we have this dual benefit here where we're slowing down ocean acidification through the production of bicarbonate and drawing down carbonic acid and carbon dioxide in the ocean.
Vesta wants to do something that might sound a little wild. It wants to mine olivine and dump it in shallow tidal areas like this all over the world. The wave action breaks down olivine even further, which speeds up carbon removal.
So our current best estimates are that for every cubic yard of olivine, we can capture 1 metric ton of carbon dioxide. The scale potential of Vesta's work is very high, and we're not limited by much. There's trillions of tons of olivine on the planet. There's thousands of miles of coastline where we could deploy it on.
When you think about it, what Vesta is proposing isn't that unusual. We've spent billions of dollars dredging and dumping sand along our coast through beach nourishment.
We have ideas of tacking on to existing beach nourishment programs of hey, you're already putting down all this sediment. What if 5% of that sand is carbon capturing sand?
There are still a lot of questions that need answering about this strategy, including the environmental impact of mining olivine at the scale Vesta is talking about. But before they do anything, Vesta wants to see if this can actually work. So they're trying to get an understanding of the chemistry in the water here at Duck before they add any olivine.
Any changes we see, we can attribute to our olivine, and this will help us really evaluate and quantify the amount of carbon that we can capture with this olivine.
It's clear that we're going to need more than olivine to solve the climate crisis, but we also need all the tools we can get our hands on, and olivine could make a big difference.
We are working up to like a 1 billion ton scale of carbon removal, which would, at that point, would really make a real difference. That's why I'm so happy to be with Vesta, because I can combine my love of the oceans and also this like intrinsic need I have to be part of the climate solution.
Thanks for watching. What other carbon capturing technologies seem feasible to you? Let us know in the comments.